Special cases. Chemistry, like life, is not always simple. You always have exceptions. So this molar ratio business that we just did works very well for most compounds. But in some cases, the math leaves us without whole numbers. So for example, here we have iron oxide. We're not sure what valence we have on iron. So we're going to use the same process, assume a 100 gram sample. And in this case, we're told that iron makes up 69.92% of this compound and oxygen is 30.08. First thing we do is we convert that to moles using the molar mass. We have the 69.92. We say that's 69.92 grams because we have a 100 gram sample. Oxygen, 30.08 grams. We divide each one by its molar mass. Iron, 55.85 grams per mole right off the periodic table. Oxygen, 16 grams per mole. And we get 1.25 and 1.88. Who's smaller? Well, 1.25, so we divide both of these by 1.25, and you can see how we've even shortened this process from the last example. And we find iron is 1 and oxygen is 1.5. So we write it as iron 1, we leave the 1 out, and oxygen 1.5. Well, that's not very elegant, and that's not fair. We can't have 1.5 atoms of oxygen. Doesn't work. So what are we going to do? Think about it for a second before you go to the next slide. Okay, did you come up with anything? Well, we had 1, right, for the iron, and we had 1.5, and we wanted an integer. Well, you can make 1.5 an integer by multiplying it by 2, but whatever you do to the oxygen to keep the same ratio of iron, have to multiply that by 2 also. So you get Fe2O3. That's the empirical formula. And that is iron parentheses 3 oxide, which we covered in a few units ago. And the 3 there means we have the iron with a +3 charge.